Okay, algebra students. Okay, so we're back again. This is actually a pretty simple problem, pretty straightforward. If you were watching my lesson, which you should be doing, there's no doubt you should be doing it. If not, this is going to be confusing, so I'm trying to make it easy on you. So the question is, what is the simplified version form of square root of 72? Now, we know simplified version of square root of 72, even though you can put this in the calculator, this is the wrong answer. Hold a second. Sorry. Clear. Square root of 72 is this decimal. They do not want the decimal. This is wrong. If you give me this on an answer, a quiz, I will park an X through it. That is not the answer. They want the simplified version. But we have a method. Our first thing is to look at all our perfect squares. Okay, 1 times 1 is 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. 14 times 14, 196. And 15 times 15 is 225. As I said, I emphasize if you work with the first 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 100. Usually you're good, but after a while of practice, you can get like me and can do all of them up to 225, pretty much in my head. Now, square root of 72. Well, first step is I'm going to take my calculator out, and I'm going to find the first number that can fit inside 72. And in my case right here, it is not 81. 81's bigger than 7, but 64. So this is how the method's going to work. First, I take 72, and I divide it by the first number that fits inside of it, which is 64. Decimal. Not good. Then I do 72, divided by the next number, 49. Decimal. Not good. 72 divided by 36. So I'm just going through here. So I said I'm divided by 64, 49, 36, and at 36 it stops. 36 times 2 is equal to 74. It's one of my perfect squares. So this number is really, square root of 72 is really square root of 36 times the square root of 2. Well, I can do the square root of 36. That's a perfect square. This number is square root of 2. So what I do is I separate them, give them each their own little house here. Square root of 36, if you know, it's 6 times 6 gives me 36. If you have to double check, you can double check on the calculator. And write second square root of 36, and you find out it's just 6. So this becomes 6. Now square root of 2. There is no number, perfect square, besides 1, that fits inside 2. 4 is bigger than 2. So square root of 1 is just square root of 1, so it doesn't really do anything. So I just leave that. 6 square root of 2. You keep trying to reduce these radicals until you get something like a 2. Let's see, some really good ones. Popular ones, not. Square root of 3 is another one. Those you can't work with. Square root of 5 you can't work with. Square root of 6 you can't work with. Square root of 7, nothing you can do. Square root of 8 is, you can actually do square root of 8. Square root of 8 is square root of 4 and square root of 2. So that would be 2 square root of 2. Square root of 9 works. Square root of 10. Square root of 11. Square root of 12 doesn't work, but square root of 13. Square root of 14, I believe, doesn't work. So all these numbers, if you get down to them, that's all your radical left. You're done. Stop. Sometimes there are weird ones that you can't do anything more with. Square root of 51. I know it's a weird one. You can't do anything with that. Some of these you stop at. When you can't do anything, if you can't do this with them, you can't do them. So our answer is 6 square root of 2.